Okay, so my presentation is on number 102. So we're given the Atwood machine with mass M1, M2, and the mass of the pulley, which is M3, and it is accelerating this way. Accelerating downwards. So M2 is accelerating downwards, and M1 would be accelerating upwards. Okay? So we start by making free body diagrams. So we know that there's a force of tension 1 and a force of gravity 1 on M1, force of tension 2 and force of gravity 2 on M2, and then on the pulley, there are four forces: force of the ceiling or whatever is holding up the pulley, force of gravity a force of gravity 3, then force of tension 1, and then force of tension 2. So first, we do our sigma F equation for mass 1. So that would be mass 1 times acceleration is equal to force of tension 1 minus force of gravity 1. Then we move on to do the same thing for mass 2. Then we go on to do the torque equation for the pulley. So that would be the net torque is equal to I alpha, which is equal to Ft1R minus Ft2R. And we know that the pulley is a disk, so we know that the I is 1/2 m3r squared, and then we can times that by alpha to get the net torque, which is Ft1r minus Ft2r. So after we do some algebra, we can solve for alpha, and then if we multiply that whole expression by r, we can solve for a. And now a is in terms of Ft1 and Ft2, and we have relationships for Ft1 and Ft2 in the first two sigma F equations. So we take those and rearrange them. So we get force of tension 1 is equal to M1A plus force of gravity 1, and then we can simplify that to M1 times A plus G. Then we get that force of tension 2 similarly is equal to M2 times G minus A. So then we plug the force of tension 1 and then the force of tension 2 back into the equation for A. And then we get this big equation for A if we substitute force of tension 1 and force of tension 2. Then through some algebra we can solve that and we get this final equation for A. Now the second part of the question asks how would it be different if we didn't consider the moment of inertia of the pulley. So now, because the pulley is not rotating, we can say that the two forces of tension are equal. So our sigma F equations would be as follows. Sigma F is equal to M1A, which is equal to Ft minus Fg1. And then sigma F is equal to M2A, is equal to Fg2 minus Ft. Okay? So then we go on and solve both of the equations for Ft, and then we equate those two equations together, and then solve for A to get this final answer. And notice that this final answer is very different from this answer. So that's why, through this problem, we realize how important it is to take into consideration the moment of inertia of the pulley. So, yeah.